So at the beginning of any algebra lesson, I usually start with what I call the A.C.D rules. A.C.D. The A stands for associative, the C stands for commutative, and the D stands for distributive. Another name for the associative property is actually called the grouping property. Okay? So let's start with the associative property. Now what this says is that if you have three numbers adding or multiplying, then the grouping makes no difference. In other words, in this case here, the first case, if I add A to B first, then add C, it would be the same result as adding B plus C first, then adding A. The same goes for multiplication. Here are some examples. If I have 3 plus 1 plus 5 and I group those, then I will get 3 plus 1 is 4. 4 plus 5 now is going to be 9. Now if I had 3 plus 1 plus 5, but I grouped it that way, I'm going to get 3 plus 5 plus 1 is 6, so I still get the 9. So it makes no difference, my grouping. Okay, so if you do the same thing with multiplication, and I would ask you to verify this for yourself, if I have 2 times 5 times 4, is it the same as 2 times 5 times 4? If I grouped those two, then I group those two. And as you'll see, it makes no difference. You're going to get the same thing. Now, moving on to commutative. This is sometimes called the order property. So when you're adding or multiplying two numbers, the order makes no difference. So if I had 3 plus 4, I'm going to get 7. But if I have 4 plus 3, I'm still going to get 7. The same thing goes for multiplying. 2 times 5 gives me 10. But 5 times 2 also gives me 10. Alright, so let's move on to the distributive. The distributive says that if I have A times B plus or minus C, we're going to be getting A times B, which is there, then A times C, which is there, and we're adding or subtracting depending on what's in the bracket. Now when we go from left to right in that direction, we say we're expanding. If we go in this direction, we say we're common factoring. Let's give two examples, one of expanding, one of common factoring. If I have 3 into x plus 4, I'm suggesting the answer is going to be 3 times x plus 3 times 4. So it's going to be 3 times x, and 3 times 4, it's 12. That's my answer. Another example, now going for common factoring. If I have A times B minus A times C, then what I could do is to factor the common A out. So I'm having my A there, then I open close bracket, I'm going to have a negative there. So if I take A times B and divide by A, I'm left only with a B. And if I take A times C and divide by A, I'm just left with a C. The check is that if we were to multiply and expand, we're going to get AB minus AC, which is exactly what we have there. Let's do another example here. If I have 3x minus 12, I hope you can see that 12 is actually the same as 3 times 4. So I could factor a 3 out, and I'm left with x minus 4. Because 3 times x gives me 3x, and 3 times 4 gives me 12. So those are the basis of the A.C.D, or associative, commutative, and distributive rules. And that will make life a little bit easier for us as we move forward. Right, so now we're going to be looking at what we call algebraic expressions, and we'll be learning how to manipulate expand, simplify, etc. Let's talk about constants and variables, operations, and also terms. So let us look at this right here. Now this is actually an algebraic expression. It has 1, 2, 3 terms. The first term is the 3, the second term is 4x, and the third term is the square root of 5y cubed. How do we know their terms? Terms are separated by minus signs, plus signs, and in the case of an equation, equal signs. So if we had something like e equals 7, so we would have another term here. Now in that case we would have 4 terms in all. But what we have just now are 3 terms. Okay? So terms are separated by plus signs, minus signs, and equal signs. All right. So a constant, let me just get rid of this. So a constant is just something like 3. So that's called the constant term. It has no x's or y's. So this is actually called the constant term. Now this term has an x. So x is what you call a variable, and so is y. So x and y are variables. Now multiplying the x here is a 4. Okay, so 4 is a constant. It's actually called the numerical coefficient of the x. And this 5 is called the numerical coefficient of the y. So that's that. Operations. Operations are just plus, minus, multiplying, and dividing. It's a way of combining things. Okay, you combine by either adding, subtracting, multiplying, and dividing. There are other ways, but these are 4 basic operations. Now, we just spoke about the associative, commutative, and distributive rule, the A.C.D rules. So if you've forgotten, just go back and review quickly, and then we'll get to simplifying some expressions using the A.C.D rules. Now let's look at number 1. Number 1 says 2x minus 5 minus 7x plus 9 minus 2y. So what we do first of all is try to combine what we call like terms. Now for like terms, you must have the same variables raised to the same exponents. The numerical coefficient doesn't matter. So let's give an example here. If I have 3x, this is the same as 5x. These are like terms, I should say, like terms. Half y and negative y, negative 6y are also like terms. 3x squared y is a like term to negative 2x squared y. The x squared y is the same variables raised to the same exponents. Numerical coefficients makes no difference. All right. X, 2xy, 2x squared y are not like terms. Not like. The good thing about like terms is that they can be combined using the distributive rule. So let's look at this one. So the like terms here is that the 2x and the 7x are like terms. So we could combine them. We could say 2x minus 7x. Notice that the 7 is being moved from the third position to the second. The reason why we're allowed to do that is because of the commutative rule. Because commute means to move from one place to another, so we could move terms around. Okay, so those are 2 like terms. Now we also have the negative 5 and the plus 9. These are also like terms. Then we have minus 2y, which is just a term with no other like terms. Now, how do we combine these? Well, we know that 2 apples minus 7 apples is going to give us negative 5 apples. But how do we do that? I'm just going to do this for teaching purposes, but you don't have to in the future. You could factor an x out. Again, this is a distributive rule, but common factoring. We factor an x out, we're left with 2 minus 7. Let's just continue with this part, which is the same as x times negative 5. But again, multiplication, we're really multiplying. Multiplying is commutative, or I should, yeah, commutative, which means that I could, the order makes no difference. So I could write this now the same as 5x. Let's do the rest. So this is negative 5 plus 9 is actually a plus 4. And then we have negative 2y plus 4 minus 2y, so plus 4 minus 2y. Now, we could also write this as, sorry, this is a negative 5x here. We could write this as negative 5x minus 2y and plus 4. It makes no difference. Just I sort of made a mistake right here. There should have been a 5x, so just make note of that. That's a negative 5x. So this now is the correct answer. Right? Let's move on to the other one. Now, just on the outside here is an implied 1, which means I could use the distributive rule. So it's not going to change anything. It's just going to be equal to 1 minus 5x plus 6x squared, and then plus 2x minus 5 minus 4x squared. Again, I could combine the like terms, and if you combine the like terms, you're going to get 6x squared minus 4x squared, which is going to give us a 2x squared. We could combine the negative 5x with the plus 2x, which is going to give us a negative 3x. Then you could combine the plus 1 with the negative 5, which is going to give us a negative 4. Now that's also correct. Let's look at number 3. It's a little bit different. Again, remember that there is an implied 1 here and an implied, well, negative 1 there. So we're going to have to do the distributive rule here. So when you have a 1, it doesn't change the value of the expression. Then we have the 1, negative 1 to the 9, and so on. So if we do this now, we're going to get 3xy minus 5xy squared minus 6. So nothing has changed. Now look at the effect of the negative 1. Negative 1 times 9, it's negative 9. Negative 1 times plus 2xy is going to give us a negative 2xy. Then we're going to have a plus 3xy squared, because negative times negative gives us a positive. And then we're going to have negative 1 times 4, which gives us a negative 4. Now let's combine the like terms. So what are the like terms here? We have 3xy along with negative 2xy, which is going to give us, well, let's write that down, 3xy minus 2xy. So that's those two terms. Then we have 5xy squared. We also have a 3xy squared, which are like terms. Negative 5xy squared plus 3xy squared. And then finally, for the constants, we have negative 6 minus 9 and minus 4. So again, we could combine the like terms using the distributive rule and common factoring, but in any case, this will work out to 3 minus 2 is just going to give us a 1xy, or just xy. Then negative 5 plus 3 is going to give us a negative 2xy squared, and then we combine the negative 6, negative 9, and negative 4 to give us a negative 19. So now that's correct. And of course, this we'll go through a little bit faster with this one. We have to use a distributive rule here, here, there, 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 and there. Let me just do the first one. 2 times 1 is 2. 2 times negative 5x is going to give us a negative 10x. 2 times 6x squared is going to give us a plus 12x squared. Yep. Now we go negative 3 times 2x squared is going to give us a negative 6x squared. Negative 3 times plus 2 gives us a negative 6. Negative 3 times negative 2x is going to give us a plus 6x. Negative 3 times negative y is going to give us a plus 3y. So just look at that for a little while. I'm going to give you like 20 seconds, and then you confirm that what we just did is correct. Okay, now let's group our like terms. Now we see that there's a 12x squared there with a negative 6x squared. So 12x squared minus 6x squared, those are like. Then we go to the x terms. There's a 10 and the 6. So we have negative 10x plus 6x. So those are like terms. Then we have the 3y. There's no other term like it, so it stands by itself, plus 3y. Then what do we have left now? We have the 2 and the negative 6. So plus 2 minus 6. Those are like. And of course, if we simplify, we get 6x squared minus 4x, then plus 3y. And we combine the 2 with the negative 6 to give us a negative 4. Number 1, x plus 3 equals 7. Now solving means that you want to find a value of x, or your variable, such that when you plug it in the left side of the equal sign, you get the same as the right side. So we want to find a value of x so that when you add x to 3, you get 7. Well, by inspection, we know that x is 4. But how do we do it? A basic rule in solving equations, linear equations, is that whatever you do to the left side, you do to the right side. So in this case, we have x plus 3 equals 7. We want to get rid of the 3. X plus 3 equals 7. We want to get rid of that 3, so we subtract 3 from both sides. So now we end up with x equals 7 minus 3. Now if you compare here to there, it is as if the 3 moved across and it became a negative 3. That is actually called transposition. Transposition is when you move a term, and what are terms? Terms are separated by plus signs, minus signs, and equal signs. So when you move a term across, it changes sign, either from right to left or left to right. So now we end up with x equals 7 minus 3, or x equals 4. Let's do this problem again. So now we could make it a little bit shorter using the idea of transposition. X plus 3 equals 7. We move the 3 across, it becomes a negative 3. So now we have x equals 7 minus 3, or x equals 4. Okay? Let's do another one. Now we have x minus 5 equals 1. So using the idea of transposition, we could move this -5 over so it becomes a +5. So we have x is equal to 1 plus 1 plus 5. So x is equal to 6. That's easy. Let's look at number 3. Number 3 says 2x equals 10. Now, we can't move the 2 over now because all of this is just one term. So that wouldn't help us at all. If we move this over, we'd get 0 equals 10 minus 2x. That doesn't take us any closer to the solution. So what we have to do this time is to divide both sides by 2. Now we end up with x equals 10 divided by 2, or 5. Fourth question. We have x divided by 3 equals 2. Now, how do we get rid of the 3? We can simply multiply both sides by 3. 3 goes, you're left with x equals 2 times 3, or x equals 6. Okay, so here's another type of problem that it's going to be a little bit more involved. So this is 2x plus 3 equals 15. Now, the first problem we had, it was either like 2x equals 15 or x plus 3 is 15, but now we're having 2x plus 3 is 15. So what do? The first thing we do is to transpose the 3. So we end up with 2x equals 15 minus 3, or 2x equals 12. Now we're back to one that we have seen before. So now we simply divide both sides by 2 to give us x is equal to 12 divided by 2, or 6. Okay, so let's move on to number 6. Number 6 says 2x plus 3 equals 5x minus 9. Now our goal is to get all the x's on one side and everything else on the other side of the equal sign. So we could keep the 2x there. We could move the 5x over, it becomes negative 5x. We could keep that negative 9 and move the 3 across, it becomes a negative 3. I'm sorry about that flickering, it's just the computer. Technology is not perfect. So now we simplify both sides. 2 minus 5, it's negative 3x. Negative 9, negative 3 is negative 12. So again, we divide both sides by negative 3. Now the negative 3 goes, you're left with x equals negative 12 divided by negative 3 is just a plus 4. Now we're almost there. All right, let's look at number 7. This is the last one. So we have 2 into x plus 1 minus 8 equals 3. So here we have to use something which is called the distributive rule. We have to get rid of all the brackets first. So the bracket, we do this, and some of you may know it by another name, but it's called the distributive rule. Some of you will say foiling, but it's actually the distributive rule. So let's do that. So 2 times x gives us 2x. 2 times 1 gives us plus 2 minus 8 equals 3. So we're back to a problem that we have seen before. So now we say 2x equals, the 3 stays, the 8, the 2 goes over, so the plus 2 goes over as a negative 2, and the 8 goes over as a plus 8. All right? So what do we have now? We have 2x equals 3 minus 2, it's 1. 1 plus 8 is 9. Then we simply divide both sides by 2 to give us x equals 9 over 2, which is quite a legitimate answer. Or we could write this as 2 into 9. It's 2 4s 8 and then 0.5. Or you could also write 4.5. Either of those would work, but because we are in the trades, engineering, or technology, we probably prefer that answer. Here are 5 steps that we use in solving a literal equation. Now, you have done all these before. You isolated a term, you simplified, transposed, and you got rid of brackets. Now we're going to be involving getting rid of fractions. So if you look at this equation here, you've seen this equation before. Technology again, folks. You've seen an equation like this, except you didn't have the bottom numbers. So we are going to show you how to solve this problem. The first thing you see here, step number 1, is to isolate or rid the fractions, get rid of the fractions. So the fraction, it's 2, 3, and 4 are in the denominator. Now, you could review what is called the LCD or LCM of the denominators. So if you look at 2, 3, and 4, the least common multiple is 12. It means that all these 3 numbers can go into 12 without a remainder, but it's also the smallest number that all these 3 numbers can divide into. 24 would work also, but it would be a common denominator, but not the least. So 12 is the least. Any common denominator will work, but the numbers get very large. So let us use the least common denominator. So what you do in this case is that you multiply each term by 12. So let's write this down again. So this is 3 into 2x minus 1 over 2 plus x over 3 equals 1 minus 2 into x plus 5 over 4. So what we do, we multiply each term by the LCD. Okay, so we're multiplying by 12 here, 12 there, 12 there, and 12 there. Now look what happens. 2 into 12 goes 6. So now we say 6 times 3 is 18 into 2x minus 1. Now we say 3 into 12 goes 4. So we end up with a plus 4x equals 12 times 1 is just 12. 4 into 12 goes 3. 3 times 2 gives us 6. So negative 6 into x plus 5. Now we are exactly back to where we were before. We just simply now move to the second step, which is to rid the brackets. So we do the distributive rule here and also there again. So 18 times 2 is 36x. 18 times 1 is negative 18 plus 4x equals 12. Now negative 6 times x is negative 6x. Negative 6 times 5 gives us negative 30. Our next move is to transpose the terms. So the 36x stays. The negative 6x goes across as a, well, the 4x actually stays there. Which is that. Then the negative 6x goes across as a plus 6x. On the right side, we have our 12. The negative 30 stays, and the negative 18 goes across as a plus 18. Simplifying both sides, we get 46x, and if you add these together, you get 0. Then our last step is to divide by 46. So that goes, and you're left with now x is equal to 0. And that's our solution. Let's do the first problem here. Keeping in mind that you go through this 5 steps. You don't necessarily need to use all of them, but we sort of start from top to bottom. Here's the first one. AX equals B. Now I can't just say solve this. I have to say solve for what variable, and I'm asking you to solve for the variable x. So we want x to be all by itself, as we did before. If we want the x all by itself, we do not want the a. So we divide both sides by a. The a goes, and you're now left with x equals b over a. Now that's as far as you could go, so that's our solution. If we knew the values of b and a, then we could go further. Okay, number 2, we have v equals u plus at, and we're being asked to solve for a. So again, what we do is that if we want to get a, we have to isolate for the a. So the first thing we do is to get rid of the u. We transpose the u, so we get v minus u equals at. And of course, to get a by itself, we divide both sides by t, the whole side by t. So now the t goes here, and you're left with a equals v minus u over t. And that's as far as we can go. Let's look at a number 3, which says m equals m subscript 0 into 1 plus alpha t, and we're solving for alpha. Now here we have brackets, so the first thing we have to do is to use the distributive rule to get rid of the brackets. So we say distribute those two, so now we end up with m0 times 1, it's m0 1, or just m0, so we could get rid of the 1. Then m0 times alpha t gives us m0 alpha t. Now we're isolating for alpha, so we have to get rid of the m0. We transpose it, so we get m minus m0 equals m0 alpha t. We want the alpha all by itself, so we divide both sides by m0 t. So now the m0 goes with the m0, the t goes, and we're just left with alpha equals m minus m0 over m0 t. That's the answer. Now don't be fancy and think you could sort of cross the m0 in the denominator out with that at the top. That could only work if there wasn't this minus sign but a multiplication. Otherwise it's going to be wrong. Okay, let's look at a fourth example here, where this is very familiar to you. V equals I over R. Many of you are familiar with this. It's Ohm's law, and we are being asked to solve for R. So let's do it here. So V equals I over R. We're trying to isolate R. Well, the first thing we have to do is to get rid of the fraction. So we multiply the both sides by R. So the R goes here, and you're left with R times V equals I. But we're isolating for R, so we divide both sides by V to get rid of the V here. And of course, you're now left with just R equals I over V. So now let's do some conversions from decimals to fractions and vice versa. So here we have a fraction, a common fraction. It's really a ratio between two values. This means 3 over 8 or 3 to 8. So there could be 3 red marbles for every 8 yellow marbles, for example. So that's the common fraction, which is a ratio. Now to convert a fraction to a decimal, so for example 3/8, you simply divide the numerator by the denominator. So for example 3/8 actually means 3 divided by 8, or you could do it this way too if you are used to this mode of division. What you have here is 3 and you're dividing by 8. Now could you put that in your calculator for me and see what you get? I'll give you a few seconds. Okay, so if you divide 3 by 8 in your calculator, you should have gotten 0.375. So 0.375 is the same as, it's a decimal equivalent to the fraction or the ratio 3/8. Now when you go the other direction, you're given now some decimals and you want to divide them. You want to get an equivalent fraction. So this is the easiest way to do it. You're going to get a fraction, so it means a number over another number. So this now, you just write this as a whole number, 56. Now, you're going to have a 1 here. How many zeros do you need? Well, how many places did you move the decimal to make it a whole number? You move this decimal place 1, 2 places, so you're going to put 2 zeros. If it were a 3, you'd have put 3 zeros. And now, you could reduce this if you just use your fraction calculator. You enter 56 over 100 and you'd get 14 over 25. You're looking for a button which looks something like A, B over C. So you'd enter 56 and then 100 after the A, B over C button, and you should get 14 over 25. Okay, the other one now. We're going to have something on top. Well, we're going to make this a whole number 4. Then a 1. How many places did we move this together for? 1, 2, 3 places. So it's going to be a 1 with 3 zeros. And if you enter that in your calculator, you're going to get 1 over 250. So we've just done going from a fraction to a decimal and also from a decimal to a fraction. Now let's talk a bit about substitution into formula. Once you have manipulated a formula or solved an equation, a literal equation, then often you'll want to substitute the values on the right, to get a numerical value. Okay? For example, here is a formula, and to the right you have variables L and G, and also there is pi, which is really a constant. So t is equal to 2 pi square root of L over G. For those of you who are interested, this is actually the formula to find the time of oscillation. So if you have like a pendulum, the time it takes to go that direction and then back to its original, that's called the periodic time, where L is the length of the string and G is what you call the acceleration due to gravity, where G is approximately equal to 9.8 meters per second squared. So we're being asked to find the t value when L is 0.25. This is actually in meters, and G is 9.81 or 9.8 roughly, 9.81 meters per second squared. So this is what we do. We say then t equals 2 pi square root. Now I usually like to put my variables in brackets. So the L value is 0.25 and my G value is 9.81. So just enter this in your calculator and you should get 1.0030 3, 3, 3, 4 roughly. Now I'm going to round this now to 1.0. That's actually in seconds. So the question is, why do I round to as 1.0? Well, let's do a recap. Where the L and the G are measurements. Because all we're doing is multiplying and dividing, we're rounding based on accuracy or number of significant digits. Now the inputs are the 0.25, which has 2 significant digits. The 9.81 has 3 significant digits. 2 is the smaller of the two, so we need to round our final answer to 2 significant digits. This one is significant, this 0, is significant because of the decimal point. All right? So that's the correct answer. Let's move on to the second example. Now, we're given the formula V equals V0 plus AT. We're given that V is 60.0, V0 is 20.0, and T is 5.00. And you want to find what A is. In fact, for those who are interested, this is for what you call an object under constant acceleration, where V0 is what you call the initial velocity, V is a velocity after a certain time t, and A is your acceleration. So let's plug it in the formula. But notice here that we want to find A. The formula is not written in terms of A, so we have to do some manipulation first. So we do V equals V0 plus AT. We want to get T, which is here. So we have to bring the V0 across. So we get V minus V0 equals AT. And to get A all by itself, we have to divide both sides by T. I know I said T there. We want to actually solve for A. So we divide by T. So the T goes, and you're now left with A equals V minus V0 over T. So now we have manipulated our formula or solved for the variable A. So now we could plug our values in. So now we could say that A is equal to, as I said to you, I like to put my values in brackets and then divided by T. So V here, V goes here, V0 goes there, and T goes there. So what is V? V is nothing but 60.0. V0 is 20.0, and T is 5.00. Right? If you work this out, you're going to get 8, but I'm suggesting that I need to write my answer as 8.00. Okay? Now, why? Well, if you look back at why, my explanation here in the first case, then you'll see why I rounded to 3 significant digits. Ratios and proportions. A ratio is just a fraction or a quotient. You're comparing two things, so A over B or A to B. So those are two ways of representing a ratio. Generally, we'll be using the fraction form A over B. Remember that A over B actually means A divided by B. That's important to remember. Now, for ratios, A and B must be in the same units. So if A is a length and B is a length, if A is measured in feet, then B also has to be in feet. If A were in feet and B in inches, we'd have to convert either to all feet or to all inches. So here is an example. We want to find the ratio of 1 foot to 15 inches. As I just said, you have to convert both to the same units. So 1 foot we know is going to be 12 inches. So it's going to be 12 to 15. Now, if we write 12 inches over 15 inches, you could see that the inches are the same, so they disappear. So you essentially just get 12 to 15, which is why you say that it is dimensionless, has no dimensions because the units cancel. So, as we said, 12 to 15 is the same as 12 over 15, which is a fraction. You put that in your calculator, or you could just do it manually. You notice that 3 can divide both, so 3 into 12 goes 4, 3 into 15 goes 5. So you get 4/5 or 4 to 5. That's the answer. Here's another one. Express the ratio 2/3 to 4/5 inches. Both are in inches. So this is the same as 2/3 to 4/5. Now this is the same as 2/3 divided by 4/5. Now this thing you see here, this whole thing, is actually called a compound fraction. It's a fraction divided by a fraction. So if you keep in mind that this bar actually means division, it's going to be the same as 2/3 divided by 4/5, which is 2/3. When you have a division, you change it to a multiplication and then multiply by the reciprocal of the fraction, which is 5/4. Then we could multiply numerators, multiply denominators. 2 5s 10, 3 4s 12, but then we reduce. 2 into 10, 5 into 12 goes 6, so it's now going to be 5/6 or 5 to 6. Okay, here's another example. If one gear has 75 teeth and the second larger gear has 120 teeth, find the ratio of the teeth between the two gears in lowest terms. So you want to get smaller to larger. So smaller first, then larger. So it's going to be 75 over 120. And if you reduce that in your calculator, you're going to get 5/8 or 5 to 8. All right? Now, a proportion. What is a proportion? A proportion is really an equality of two ratios. What is it? An equality of two ratios. So here we have a proportion. This is a proportion because I have A over B, which is a ratio. I have C over D, which is another ratio. And if I make them equal, then now I have a proportion. And of course, you could solve for either A, B, C, or D using the method of solving equations, which we learned earlier. So now we're going to move on to solving 3 equations really involving proportions. Now let's look at this first example here. The first example says, it is reported that the number of conservatives to liberals in Canada is 4.6, so that's a number of conservatives, well, not number, but the ratio, to the liberals, which is going to be 3.1. So we could write here conservatives over liberals, right? Conservatives is 2.6, liberals 3.1. So conservatives on the top, liberals at the bottom. Now it says, assuming that this ratio holds true for Peterborough, determine the number of conservatives, so that's what you want to find, if there are this number, 26,300 liberals. So here we're going to form now a proportion. So we know the number of liberals is 26,300 liberals. And you want to know how many conservatives. You see, we know conservatives on the top, liberals the bottom, conservatives, liberals. So now it's a matter of solving for C. How do we solve for C? Well, let's rewrite this. 2.6 over 3.1 is the same as C over 26,300, right? Now, how do we get the C all by itself? Well, what we could do here is to multiply both sides. Remember, we talked about the LCD. We could just multiply the 3.1 and the 26,300 together, a common denominator. So I'm going to put 3.1 there and 26,300. So I'm multiplying the right side, so I have to do the same here. 3.1 and then 26,300. Look what happens now. The 3.1 goes with that, and the 26,300 goes with that. So what are we left with? We're left with 26,300 times 2.6 equals 3.1 C. Now you might be saying, why did I put the C after? Remember we talked about the commutative rule or the order property. The order makes no difference. Now to get C by itself, now we just simply divide both sides by 3.1. So that goes, and now you're left with C equals 26,300 times 2.6 all over 3.1. And if you do that, you will get approximately 22,058 conservatives. Now, the last question here will be just like what we did in solving equations involving fractions. But again, if you look at this side, you could see that it's a ratio and another ratio on the right. So two ratios set equal to each other. It's called a proportion. So how do we solve this? Well, let's rewrite it. X minus 2 over 3 equals 2x plus 1 over 4. So always go to put these things in brackets. Now the LCD is 12, 3 and 4. The LCD is 12. So I multiply this side by 12, the right side and also the left side by 12. Look what happens when I do that. I can reduce 3 into itself 1, 3 to 12 goes 4. So I'm left with 4 into x minus 2. And the right side, 4 into 12 goes 3. So I'm left with 3 into 2x plus 1. Now I can see that you're already saying, wow, I know how to do this. And next apply the distributive rule. So 4 times x gives me 4x, 4 times negative 2 gives me negative 8, then 3 times 2x gives me 6x, and then 3 times 1 gives me plus 3. Then next I transpose 4x, then minus 2x equals 3 plus 8. You can see where that's coming from. Now I simplify both sides. I'm going to get negative 2x equals 8 and 3, 11. Then my last step is to divide both sides by the numerical coefficient of the negative 2x, so negative 2. Negative 2 will go, and I'm left with x equals negative 11 over 2. Let us now look at what we call direct and indirect variation. Okay, let's look at this question, this statement here. The more you study, the higher your marks. So for example, you put 3 hours of study in, you get 30%, 6 hours of study, you get 60%, 10 hours of study, you get 100%, 0 hours of study, well, you fill in the blanks from there. So if we say that y is directly proportional to x, we write it like this. Y is directly proportional to, that's this alpha sign, to x. Now, to make this into an equation, we write y equals kx. The purpose of this, the whole essence of this is we want to be able to solve problems. Okay? So what we do is we isolate for k. So we say therefore k is equal to y over x. So that's what we end up with. Now, what does this mean? It means that regardless of what the y values and the x values are, if we divide y by x, we get the same k value. So what we could say then is that k is equal to y1 over x1, which is the same as y2 over x2, and we could keep going. Now have you noticed here that right here now we have what is called a proportion. It's two ratios being equal. So now we could solve equations. So without any further ado, let us just see how we could solve an equation for this. But just keep in mind one important fact. As long as y is proportional to x, you could write y1 over x1 equals y2 over x2, etc. If I say that v is proportional to w, you could write v1 over w1 equals v2 over w2, etc. So let's do a problem. R varies directly as L. So what does that mean? We could write R1 over L1, that means our set of R and L's, would be equal to our second set of R's divided by our second set of L's. So R1 over L1 is R2 over L2. Okay, so now we have a proportion. So let's see how we could solve. So now this question says, when R is 20, when L is 15. So we could put that on, that's our R1 and L1 values. So R goes on top, so that you could say that 20 and L is 15. And it says now, second part, find R when L is 45. Well, L goes in the bottom. See, L in the denominator, R in the numerator. So when L is 45, so we put our 45 there, it says find the R value. So that's our R or R2 value. Okay, so now how do we find that? Okay, well, that's not bad. So now, again, we could multiply, we could multiply both sides by 15 times 45, and on this side 15 times 45. Now look what happens. The 45 goes, the 15 goes, I'm left with 20 times 45 equals 15 times R. Let me just show you something right here which would probably help you a bit. Let's get rid of this here, and let's get rid of this here. Now look what happens. It is as if, let me get another color here. Once I have a proportion, it is as if when I multiply these two together, 20 times 45, that's on the left side, and 15 times R, which is there. So sort of if you have a proportion, when you cross multiply, then the results are going to be the same. So that's another way of solving these equations. Right? Now how do I solve for R? Well, I divide both sides by 15. So the 15 goes, and I'm now left with R equals 20 times 45 over 15. You could put this in your calculator, or you could say 15 into 45 goes 3, 20 gives me 60. Okay, so that's my answer for that section. Now here's another example. It is asking you to fill the spaces here and there. Okay, but here's your x1, y1 value. It says that y value varies directly as x. So what do we know? We know that now 10 over 12, which is the same as what? This can be reduced to 5 over 6. So we could say that 5 over 6. Okay, you could go 6 over 5 too, but notice on top here we have the 5 is now the x value, and that's your y value. It doesn't make a difference whether you say x over y or y over x. The important thing is that once you get your second ratio, if you have whatever you have on top has to be on top again. So 5 is your x value, 6 is your y value. So here now we have 7, which is an x value. So we could say that's 7 over the y value. So let's put y there. So again, we know that 6 times 7 is equal to 5 times y. So y is 6 times 7 divided by 5, which you could verify that's 8.4. So that's our first answer. Now let's do this with the y on top now. So, and let's not reduce, just for variety. So we know that y1 over x1 equals y2 over x2. Let's do it this way. So the y1 value is your 12 over 10, and your y2 value now is 20, and the x value is what you don't know. So let's put x. So again, we have 12x, which is going that way, is equal to 10 times 20. So x is equal to 10 times 20 over 12, which is just about 16.7. All right, and that's the answer. Let's move on now to something quite similar. Now, y, in the previous example, y varied directly as x. It could be that y varied as x squared, or y varied as x cubed, or y varied as x to the 4th, or whatever. So generally, you could have y varying as x to the n. Okay, so again, just as in the previous case, we have y1 over x1 now to the n equals y2 over x2 to the n, etc. Let's move on to an example to see how this is done. Okay, the distance an object falls, right? So we could call that, for example, d, is directly proportional to the square of its time. So we could say that's directly proportional to t squared, right? So what do we know from this? We know that d1 over t1 squared, it's d2 over t2 squared. Now, how do we solve an equation now? So it says if the time is 2 seconds when the distance is 19.6, so this is our t1 and d1, so we could say therefore this 2 seconds is our time, so we're going to have 2 squared, and our d is 19.6 meters, and that is second squared. Now, and it says determine the distance, so we want to find a distance, so we're going to put our d there, or d2, and time is 5.6, so 5.6 squared. How do we solve for d2? I'm sure you could verify this, that d2 is going to be equal to 19.6 times 5.6 squared, and then you divide by 2 squared. Okay, and that works out to be about 153.664 meters, which we have to round to 150 meters, and I'm sure you see why that needs to be the case. Right? Now the second part says now you want to find the time, so you want to find the time. So the first part remains the same, 19.6 over 2 squared, that's coming from what's given right there. That's your t1 and d1 values. But now you want to find the time. Time was at the bottom. So we're going to have t squared. And your distance is going to be your 95.6. Okay? So now if you solve for t squared, you're going to get t squared is equal to 2 squared times 95.6 divided by 19.6. And of course, to find t, I just take the square root of both sides. So now I end up with a t alone. And if you work that out, you should get 4.42 seconds. All right. Now, here's your last example for direct variation. It is known that the area of an object, so let's call that A, is proportional to the square root of its height. So the square root of its height. So what do we know then? We know that A1 over the square root of H1 must be equal to A2 over the square root of H2. Good. So what do we know now? Therefore, same thing again. We know that H is 15 when A is 10. So when A is 10.0, we need to have the square root of H, which is 5.00. And it says find A is at the top when H is equal to 80. So we need to find the root of 80 centimeters. And of course, if you solve this, well, we know that A then will be equal to 10.0 times the square root of 80, and you're dividing by the root of 5.00, and this works out to be exactly 40 centimeters squared. Okay. We're now on to what is called indirect variation. Let's look at this example. The faster you drive, so let's call that your velocity, say v. The faster you drive, the less time it takes to reach your destination, that's t. Now, contrary to direct variation, as one increases, the other one increases. The more time you spend studying, the greater your mark. The less time you spend studying, the less your marks. But in this case, as one goes up, the other goes down. As you go faster, the time you take decreases. As one increases, the other decreases. So this is where indirect variation comes in. As one increases, the other decreases. So in this case, for direct variation, we wrote v proportional to t. But in this case, we know that they are inverse proportional. So the faster you drive, you could say that v then is proportional to 1 over t. Or you could have written it this way too, t proportional to 1 over v. It's the same thing, right? As one goes up, the other goes down. So that's the important thing. Now to make this into an equation, you could now say t equals k times 1 over v, or k over v. And solving for k, we could say therefore k is equal to tv. Hence, as we did before, we could say that t1 v1 equals t2 v2. So keep this in mind. For direct variation, we divide, but for indirect variation, we multiply, as in this case. All right? So let's try an example here. Given that y is inversely proportional to x. So that tells us what? Right? That tells us that x1, y1 equals x2, y2. Remember, for direct variation we divide, for indirect variation we multiply. So here is our y1 and x1. So our x1 is 1.7. We multiply by y1, which is 10. And it says find y, so you don't know what your y or y2 is, but you know that your x2 is 0.25. And of course, to solve for y2, we just simply take the left side, which is 1.7 times 10, and divide by 0.25. And of course, you get y2 is 68. And we go to 2 significant digits. Okay, now here is our final example. If it takes 3 painters 24 days to paint off the rooms in a motel, how many painters are needed to paint off all rooms? So in this case, it's obvious that it's indirect variation. If you sort of read right here, right, it says examples involving RPM, revolutions per minute, diameter of a pulley, RPM and teeth on a gear, distance and force across a fulcrum, and also the number of people working on a project. All of these are indirect. Because if you have a job to be done, the more people on the job, it will take less time. As you increase the number of people, the time it takes goes down. So it has to be direct. It has to be indirect, sorry. It can't be direct. As one increases, as you increase your workforce, the number of people, then the time the job takes to be done goes down. So we know that this is an indirect variation. So number of painters, I'm going to call P. So we know that P1, and the time it takes, let's call that T, so that's T1, is equal to P2 times T2. Right? So let's see what we're given to solve this problem. Now, it takes 3 painters 24 days. So we could write 3, and I'm just going to write it here, painters 24 days. And that's now equal to, well, it says how many painters, so we don't know the number of painters. Okay, so we're going to write P for number of painters in 8 working days. So I'm going to write 8 days. Now in solving now, we must have then P is equal to the left side, which is 3 painters times 24 days, and you're dividing by the coefficient of P, which is your 8 days. Now look at what magically happens here. Your days will cancel and you're left with painters, which is what we expect. So if we multiply 3 by 24 and divide by 8, we're going to get 9, and that has to be painters, which makes a lot of sense.